Very good morning, students. This is Jay Vishakan. For this lecturing video session, I'm going to take a topic from Unit 2, which is cost-output relationship in long-run cost function. Let's see the meaning of long-run cost function. In the long run, the size of an industry can be expanded to meet the increased demand for products such as in long run, all the factors of production can be increased according to need, which means all the factors are variable. So this long run cost function is influenced by law of return scale. So which means the all the factors are variable, isn't it? Hence, long-run costs are those which vary with output, and all input, including plant, equipments, everything vary. In order to study the cost-output relationship in the long run, it is necessary to know the meaning of long run. As known in the long run, the size of the industry can be expanded to meet the increased demand for products. As such, in the long run, all the factors of production can be varied according to the need. Hence, long run costs are those which vary output and all the input including plant and equipment vary. So let's see a graphical representation. In the x-axis, it has been considered as output, that is OX, and OY as the total cost. So here you could see a series of SAC curve. So SAC curve is nothing but the short run average cost curve. All these SAC 1, 2, 3 are short run average cost curve. And LAC is nothing but the long run average cost curve. Okay. So here if you just look at this, the long run average curve also known as the envelope curve or planning curve. Why does it be called as envelope curve? This LSB, why does we call this long run average cost curve as envelope curve? This curve envelopes, this LAC curve envelopes all the short run average cost curves, and hence it is termed as envelope curve. The main implication of this envelope curve is that the long run average cost cannot exceed short run average curve. Since in the long run, indivisible factors are fully utilized, and thus the long run average cost will surround the short run average cost. This will not intersect the SAA cost while rising in upward direction. So look at here, while rising upwards, it won't intersect of the LAC curve. Okay. See, as per the above picture, there is a picture which is shown, that graph which is shown. Suppose that at a given time, the firm operate under an SA2 and produces out OQ. So this is SAC2, right? This is the curve. And the output is OQ. So as far as SAC1 curve is concerned, the output is OP. So as far as SAC T curve is concerned, the output is OR. Right. If the firm decide to produce the output OR and continues with the current plan SAC2, its average cost will be QR. If a firm decides to increase the size of the plan to plan SAC3, its average cost of producing OR would be then TR. Since cost TR is less than the cost of old plan UR, therefore new plan SAC3 is preferable and should be adopted. Thus the long run cost of producing OR output will be TR, which can be obtained by increasing the plan size. See, as a producer, what will you choose? Which curve you will choose? Either the output, OP, SAC1, or the quantity OQ, SAC2, or OR, SAC3. See, at this point, you just look at here, the average cost at the minimum. This here, they look at the point SAC2, this Q. Here, the average cost is minimum. So, the maximum profit would be obtained. But look at the quantity. The quantity is not that large. That is it's not for the large scale of production. So as a producer, OR, the firm will choose OR. The producer will select this. The reason behind the quantity is more and the reasonable margin, that is a profit, would obtain. So that's the cost of production. OR would be TR, which can be obtained by increasing the plant size. To draw long run average cost curve, that is LAC, we start with the number of short run average curves. So each such curve representing a particular size of the plan, including the optimum plan. One can now draw a LAC curve which is tangential to all SAC curve. So look at here, see all the SAC curves, the LAC passing through the tangentially. LAC passing through tangentially to all the SAC curve. That is the short run average cost curve. So look at here, everything is passing through the tangential. That's what it says here. In this connection, the following features are highlighted. The LAC curve envelopes the SAC curve and it is therefore called as envelope curve or planning curve. Right. Each point of LAC is a point of tangency with the corresponding SAC curve, which I just shown in the graph itself. The points of tangency on the falling part of SAC curve for points lying to the left of minimum point of LAC. The points of tangency occur on the rising part of the SAC curve or the points lying to the right of minimum point of LAC. The optimum scale of plan is a term applied to the most efficient of all the scales of plans available. This scale of point is the one whose SAC curve forms the minimum point of LAC curve. So it is SA3 in our case which is tangent to LAC curve at its minimum point at R. So both LAC and SAC curves are U-shaped. Right? So if you just look at the graph, so look at this, all the SAC curves and LAC curves are of U-shaped. But the difference between the U-shapes is that U-shape of the LAC is flatter, right? It's wider, so it's a flatter or lesser pronounced from bottom. The main reason for is that in the long run such economies are possible which cannot be had in the short run, right? Likewise, some of the diseconomies which are faced in short run may not be faced in the long run. So this is the explanation for the long run average cost curve. There is a relations between the cost and output relationship in long run. So as a producer, the point which will be chosen on the output is OR, so that the producer get maximum quantity and the handsome profit. So this is for the long run business. So of course, as a producer, he will definitely focus on the profit and the quantity. Right. Hope you have all understood the concept of the long run cost function. Thank you.